So this is the first of 3 videos that we're going to go through and do today. We're going to go through and do what's known as establishing the identity. And what we do is we are starting with an equation, and it's our job to show that this left side and this right side are equal using the identities that we know. All right, so for example, I'm going to start with one side of the equation. This is different than when trying to solve an equation. When we go to solve an equation, we just go through and we can manipulate both sides. But when establishing the identity, we're trying to figure out if this left side does indeed equal this right side. So what we need to do is we work with the expression on the left and the expression on the left only. And hopefully we go through and do enough of the adjustments to the equation, or sorry, just to that part of the expression, to get it so that the left-hand side turns out to be exactly what the right-hand side is already at. So we'll just go ahead and get started right off the bat with the first example. So the first thing to do is to rewrite the left-hand side of the equation. So I've got sine theta cosecant theta minus, well, I don't know why that doesn't look like a cosecant. There you go. Cosecant theta minus cosine squared theta. Eventually, we want it to equal this. But when establishing an identity, I can only work with one side. So usually, as a rule of thumb, you're going to work with the side that has the most opportunities for you to go through and make adjustments. So if I look at the left-hand side right now, I know that cosecant is nothing more than 1 over sine. So I'm going to change these using all of the identities I already know. So I already know the reciprocal identities, quotient identities, Pythagorean identities. So I'm going to use those to adjust or to substitute other expressions on the left-hand side. All right, so the way that we're going to do this, we're going to take a look at, I've got sine theta, that's not going to change any, but cosecant is nothing more than 1 divided by sine theta. And then we're going to subtract from that cosine 2 theta. So my next step is, all right, well, now I can simplify this. The sine and the sine actually cancel each other out, and I'm left with 1 minus cosine squared theta. All right, so what did that do for us? Well, I want it to be sine squared theta is the only thing that's left here. So somehow I have to introduce sine squared theta. Well, remember 1, based on the Pythagorean identity, 1 is equal to sine squared theta plus cosine squared theta. And then we now take what is left here minus cosine squared theta. Simplify this expression. Well, cosine squared theta minus cosine squared theta, that goes out to be 0, and I'm left with sine squared theta. So what we've done is we've gone through, taken the left-hand side, adjusted it using all of our trig identities, done the mathematics over here, and we got to the end having exactly what we wanted it to become. All right, we're going to do 3 examples in this section, and then we've got 2 more videos doing 1 example each. For our second example, we've got to go through and, again, look at the left-hand side because that's the one that has the most opportunity to go through and make some adjustments to it. So we're going to rewrite the left-hand side first. So I'm going to end up with cosine squared theta, and then in parentheses 1 plus tangent squared theta. And that equals, I don't know yet, but I do want to get so that at the end I'm equaling 1 at some point. Now, another rule of thumb is if I have cosine or sine and a tangent or a cotangent, that I will want to change the tangent or cotangent into sine and cosine. If I were to have a cotangent here and a tangent here, then the rule of thumb is leave it in tangents. Put everybody into tangent and roll from there. Okay, so here I have a cosine on the outside and I've got a tangent on the inside. So my first step is going to be to rewrite the tangent piece as sine over cosine. And in this case, it's going to be squared. So sine squared theta divided by cosine squared theta. All right. And then what I'm going to end up doing is just use my normal properties. And what we're really doing is just simplifying expressions to see if I can get them to turn out to what I'm looking for. So I'm going to distribute this cosine squared theta to each one. And when I do that, cosine squared theta times 1 is cosine squared theta. Plus, then when I distribute here, I'm going to get sine squared theta. And actually, I'm going to write out this extra step. I wouldn't usually write this extra step out, but I want you to see what's going on. So my numerator is this. My denominator is still this. So what happens here is that the cosine squareds actually simplify out, and I'm left with cosine squared theta plus sine squared theta. Well, we just did an example, and using the Pythagorean identity, we know that sine squared theta plus cosine squared theta is equal to 1. We also know that addition is commutative, meaning it doesn't matter what order. So whether I say sine squared theta plus cosine squared theta, or I reverse the order and say cosine squared theta plus sine squared theta, it doesn't matter. Both of these things equal 1. Now, there are multiple ways at which to go through and do this exact same problem. Some instances you can do it in less steps. Other instances you can do it in a lot more steps. It doesn't matter as long as all of your mathematics is true, as long as you're following the directions for math, as long as you're using proper rules, as long as you're using the proper laws, that's fine. You just have to be careful not to make errors. So it's kind of like, we can take a direct route and leave Charahoe and drive up to the city of Providence, Rhode Island in a straight shot. Or we could go south to New York, take a different route, and go up to Boston. Either way, you get to the same ending point. It's not how you get there, it's that you get there and you got there correctly. All right. Okay, our next example I'm going to deal with is if you look at this here, it's different than what we were looking at before. All right, I've got a fraction on this side. It's not something that's as simple as what we were looking at before. And then I look here and I've got secant theta minus tangent theta. So I'm going to try to see if there's something here that I can work with to get me to this side. And it doesn't matter which side I start with. But I like to start with the ones that look like this. It's a little bit easier when possible, but I could start here. Problem is, if I start with the stuff that's on the right, I don't really have anywhere to go. I've got cosine, I've got sine. There's nothing I can simplify. But when I look over here, I've got secant theta, tangent theta. My first steps is to turn everybody into sine and cosine, and then let's see where it goes. So that's what we're going to do. We're going to go through and do secant theta. Whoops, forgot the C. Secant theta minus tangent theta. And again, I have to write this side first. Then I can start manipulating what is on this side and then eventually get to what we're looking for. All right, so now the first thing I'm going to do is turn these guys into sine and cosine. So secant theta is 1 divided by cosine theta. And then tangent theta is just sine theta divided by cosine theta. All right, so we're going to combine these two fractions. So if I bring them together, I've got common denominators. So I get 1 minus sine theta divided by cosine theta. All right, so this is not at all what we're looking for. This did not turn into it what I want. So now the thought is, all right, well, how do I get it to turn into what I want? What can I do to turn it into that? So when we're totally different, the idea now is I need to introduce what I need over here because it's not there. All right, so you're now thinking, Maine, how am I going to do that? How do I just introduce something that I'm looking for? Well, the nice thing is it's in a fraction. So I introduce 1 plus sine theta to the denominator because that's what I need it to eventually be. And in the numerator, I'm going to introduce 1 plus sine theta. All I've done is this is 1. That's all I've done. I've just changed this to a 1, and now I'm going to go through and work on it to see if I can get it to become what I need. So now I'm going to end up with, in my numerator, 1 minus sine theta times 1 plus sine theta, all divided by cosine theta times 1 plus sine theta. Now, a lot of you from the experience that I've seen in the past will be like, oh, sweet, now I can get rid of these two things. And then I'm left with this, and wait a minute, we haven't done anything. Yeah, you don't want to do that. So we've got to go through now and multiply that numerator. Problem is I'm running out of room here, so I'm going to try to squeeze it in here, but then you would have a whole sheet of paper, so you'd be able to keep going, one right underneath the other. Since I'm running out of room, I'm going to try one here, and then I'm going to pull myself over here to start the next column. But when you do this on your own, you need to have it so it goes down all the way through until you solve, and you're done. Okay, so when I go through and do this, this is a difference of two squares. So I know what this is when I go through and multiply it all out. I know I'm not going to have a middle term, but I'm going to take the 1, distribute, negative sign, distribute, and hopefully we know that when we see a difference of two squares, I end up with the first term squared, which is 1, the opposite sign, because I've got a positive times a negative, and then the last term squared, so sine squared theta. And this is going to be over, hopefully we can fit this in, cosine theta times 1 plus sine theta. All right, like I said, I have to bring this up here. But if you're doing this for real and you're doing this for a quiz or you're doing this for a test, even for your practice problems, you need to go through and make sure it all comes down in one column, if you will. All right. So my numerator is 1 minus sine squared theta. Okay, so I've got a sine squared. Somehow I got to get cosine up here. All right, well, the way to get cosine up here is, remember, I have 1. 1 is the sine squared theta plus cosine squared theta. So I'm going to substitute 1 for sine squared theta plus cosine squared theta. And then I still have that minus, and I hope I can fit this in here, sine squared theta. Talk about just fitting it. Divided by cosine theta times 1 plus sine theta. All right, so let's see what the next one brings. All right, we got sine squared theta here. I do have a minus sine squared theta here, so when these two things, they will just add out to 0. So I'm left then in the numerator with just cosine squared theta. My denominator still has the cosine theta, and it still has the 1 plus sine theta. Hopefully we're starting to see what's going to happen here. I've got a square term here, and I've got a singular term here. So this is like if I had x squared up here and an x down here. Simplify it. So this would become a cosine theta in the numerator. And my denominator, because this is now gone, I'm left with just the 1 plus sine theta, which is exactly what we are trying to get up here. So hopefully as you go through some of the things that, I can't show you every possible thing that could happen. But the idea is, oh yeah, this looks like something I can do here. Or try to get the idea of when I have a situation like X, then this is what I need to do. Okay, so for example, the very first thing we did here, I know I need sine and cosine. These are not in sine and cosine, so let's get them into sine and cosine and work from there. Okay, so the goal is I can't show you every single thing, but I can give you some options in case something like it pops up, and then you can work from there. All right, so this is a rather long one in comparison, but hopefully this was helpful. We've got 2 more of these to go through other options. So again, thank you very much for your time. If this was helpful for you, go ahead and like our Charahoe YouTube page for the pre-calculus, Charahoe pre-calculus YouTube page, and that way you're updated on all of the future videos. Thank you, and have a great rest of your evening.